Good morning, students. So previously we had seen one technique to wherein devices could commonly share a media for transmitting or receiving their data. And that technique was given the name random access technique. If you all remember, we had discussed number one, a technique called as Aloha, which is further divided into pure and slotted Aloha, and another technique which is called as carrier sense multiple access CSMA, which when you all if you all recollect, further comprises of three sub techniques. Number one, non-persistent CSMA. Number two, one persistent CSMA, and number three, p-persistent CSMA. Moving on, the second technique of wherein devices can parallelly transmit data, or rather I would say where devices can share the media commonly for communication. The technique goes by the name controlled access or scheduling. Now, if you go by the literal meaning of the word scheduling, I think it becomes very clear, wherein every device is going to get a chance to to transmit at a slot that may be assigned to it. So basically, we are talking of an ordered access to every device to the shared media, so that every device or station will get a fair chance to transmit its data. That is why it's written over there, a fair protocol or a fair technique. Now, if all the devices that are using the shared media transmit their data in an ordered fashion, this technique can help to eliminate collision completely. Further, if you look at scheduling, it is comprising of three types or three techniques. Number one is reservation, number two is polling, and number three is token passing. As discussed earlier, just reviewing what was discussed with regards to reservation access method. If you look at the figure, there is a white section which is called as the reservation frame, and then you have the blue section which is the data frame that every station is having to transmit or is ready with to transmit. So how does this particular technique work? Number one, there is this reservation frame that comprises of several mini slots, and every device is assigned a particular mini slot, which means the device can only transmit data in the slot that has been assigned to it. Okay. So if you read point number one, it says that every station can transmit a single frame at the full rate of the channel, provided it is transmitting in the mini slot that has been assigned to it. Whenever a station has a frame to send, that frame will have to follow the reservation frame only. So it is like saying that once the reservation frame is transmitted into the media, following that will be the data frame which a particular station may have to transmit. So if you look at the figure, let's say that station number one has a data frame to send. So the mini slot number one, which has been assigned to station number one, will be used for sending the data of station one. By sending a reservation frame through the media, other stations will also have an idea of which stations are ready with data to send, so that any other station will not transmit its data apart from the slot that it has been assigned with. Okay, so if you read point number 4, it says that whenever any station wants to send a data frame, it has to make a reservation in its own mini slot. So if I take the example further, if you see there are three stations. Initially, there was one station, number one, which had a frame to send. So the reservation frames slot number one was colored yellow, which is an indication that currently station number one is transmitting its data. Then let us say that station number one, station number three, and station number four are having data frames to send, so they can transmit only in the mini slot for which they have made the reservation. That is why slot number 134 has been colored yellow, which is an indication to other devices in that particular medium that there are currently 3 devices which are having their respective frames to send. So this is the technique of reservation access method. The second technique is called as polling. Now this polling comprises of further 2 types. There is something called as centralized polling, and then there is something called as distributed polling. If I talk of centralized polling, it would be like a typical example of a master-slave architecture where you will have one device which acts like the master and all the other devices will then act like a slave. So that context is how this particular technique would work. And in distributed polling, you don't have a concept of slave and master. So it's more like a peer-to-peer, devices that are communicating with each other. So coming back to centralized polling, in centralized polling, like I just said, there is going to be one device that is going to act like a primary station and all the other devices will act like the secondary station. So whatever data exchange happens will always happen through the primary station. So whenever the primary station is having a frame to send to a particular secondary station, initially it will send a select frame. That frame is going to comprise of the address of the intended secondary station for whom a data is going to be transmitted. This is when primary is sending the data. But if it's the other way around, instead of sending the data, the primary station is required to receive the data. What it will do, it is going to send a frame called as a poll frame to every device, or rather I would say every secondary device, asking those secondary device if they have any data to send or not. If any secondary station is having some data to send, it will transmit to the primary station. Otherwise, the secondary station will simply send a NAK frame. No acknowledgement. Matlab, there is nothing that that particular station is having to send. Typically, the order by which every secondary station would transmit data to the primary or primary would send to every secondary station would follow some kind of an order. So either it would be a round robin fashion, like first number 1, then number 2, then number 3, so on. Or there could be some kind of a predetermined order which every station is required to follow whenever it is required to send the data. So if I just show you the figure for this particular description, the left-hand side figure is when the primary station is having a data to send to the secondary station. So how the process is, whenever primary wants to send data to any secondary station, it will first send a select frame that comprises of the address of the intended secondary station. So that frame will go to the intended secondary station, which the secondary station is required to acknowledge. Once that acknowledgement is received, primary station will then transmit the required data frame to that secondary station, which again the secondary station is required to acknowledge. This is when the direction of flow is from primary to any secondary. Now, if primary wants to receive some data from any secondary device, what it will do? It will initially send a poll frame to every secondary station in a particular order. If any secondary station is having a frame to send, it will send a frame back to the primary, which the primary is supposed to acknowledge. However, if no secondary station is having any data to send, then those secondary stations will simply send back a frame called as NAK, which is basically a no acknowledgement frame. So this is your, centralized polling technique. Coming back to distributed polling technique, like I said, this is more like a peer-to-peer communication where you don't have a concept of master slave or primary secondary, which means any station can send data to any other station. However, what is required is that there has to be a certain polling order. Okay, so either that order could be round robin, first followed by second, followed by third, followed by fourth, and so on. Or it could be a predetermined polling order wherein the station with the highest priority will always have the access to transmit first. So once that station has done the needful, it will then pass on the access right to the next highest priority station. How does it do? Every previous station that has already sent its data will send something called as a pulling message, some indicator to the next highest priority station, telling that station that now you can start with your transmission. So if there is a known order, then every previous station has to pass the right to send data to the next highest priority device, and this is how communication will keep on continuing. So these are the techniques that come under the category of polling. That's number 2. And last is the third technique, which is called as token passing technique. Now, in this technique, this technique would work preferably for a ring network, which we've covered in our first module of CCN. So every device is connected to every other device through a token ring network. So what is this token that we are talking about? I shall let know in few seconds. But how does it work? Now, in a network where every device is connected to every other device in the form of a ring network, so basically every device is doing two things. It is listening, so it goes to the listen state, and it's also transmitting. So if a device is going to if a device is expecting a data, what it will do, it will keep on listening to every arriving bit, and it will check the destination address that is corresponding to that particular arriving frame. If the destination address is its own address, what will that station do? It will copy the data that has come incoming to it. If the destination address is not that of its own address, it will simply pass it to the next station through its output port. Now, this is the listen state, where every device is simply listening to the media to check for any incoming frame. And then you have a transmit state, wherein a station that has a frame, or rather a station that wants to send a frame, it will then go into the transmit state. So for any station in this particular network to transmit a frame, it requires something called as a token, a free token. So there is always a free token. Okay, it's like a capsule. If I have to give you an analogy, a capsule that will keep on circulating within the network. Whichever device gets hold of that token can use that token to insert its frame and then transmit it out into the network. If the token comes to a particular station and that station does not have any frame to send, it will simply pass on that token. Okay, now whichever station is having hold of the token currently, it is responsible for reinserting the free token into the ring medium if it has no data to send. And if it has already fit in a data and passed on into the network, when the same token comes back to it, because it's a ring network, so when the same token comes back to it, that station is also responsible for removing the transmitted frame, so that now the token will be released. It will become a free token and can be used by some other device in the network. Okay, for transmit state and for listen state, for both, if I have to show you a flow chart, simple flow chart. So how would the transmit state of this particular technique work? So every device is going to wait for a token, because only via the token can any device send its data. So when a token is circulating in the network, and if it is arriving at a particular station, if that station is having data to send, so firstly it will capture the token. If it doesn't have a frame to send, it will release the token so that it can then move on to the other device in a ring fashion. However, if that station is having a token to send, what it will do, it will send its frame through the token that will circulate within the network. Now the token can stay with the device only for a particular period of time. Otherwise, what will happen? Only one device will have, a more access to that particular token. So every device can use the token for a particular period of time. So let us assume that a particular station has put its frame and released the token into the network. Let's assume that the token has come back to the station. There is still some time for which the station can hold on to the token. So if the allocated time has expired, if it's a yes, the device has no option but to release the token and wait for its turn again sometime later. If the allocated time for within which it can use the token has not expired, it can then continue to send the next frame. So as long as you are having your stipulated time to hold on to the token, you can keep on sending the frames that you wish to send within the network. The moment the allocated time for which you are allowed to use that token expires, your device is required to release the token into the network so that the next device can get access to it. So these are the 3 techniques of scheduling. Number 1, reservation access method. Number 2, polling. And number 3, token passing network.